Think of a road. It is made entirely from a material that comes from nature. You will be surprised, but this material is actually a tropical fruit that we all know, coconut. But where did this idea come from? Let's discover all the steps of this extraordinary process together. It all starts in the southern states of India, where the tropical climate prevails. Here, coconut is not just a fruit, it is a source of income for thousands of farmers, a natural raw material used for thousands of years. Coconuts are knocked down from the trees by hand or with special long sticks. First, they are stacked to be separated from their shells. But the shell we are talking about here is not the thin membrane we know. It is the 5 to 7 centimeter thick, fiber-rich, hard, and very durable outer cover surrounding the fruit. This outer layer is called the husk. The collected fruits are subjected to a dehusking process, using sharp-bladed manual tools to separate the outer layer. Hundreds of workers repeat this process throughout the day, sometimes with just their bare hands. What emerges is a raw coconut shell. It is rough, damp, and unusable in its current state, but it contains such a potential for fiber that it only takes a few industrial steps to release it. Now it's time to expose the fibers inside the shell. Large machines called breakers are used for this. As these machines crush the coconut shells with rotating shredders that resemble hammers, the fibers and woody parts begin to separate from each other. This process is not an ordinary crushing, but a balancing process that must be done carefully. Because no matter how strong the fibers are, they can break if too much force is applied. The fibrous structure is cleaned of coarse particles. Then it is turned several times in rotating drums to separate the long, strong fibers. Short fibers, woody dust, soft particles called pith are thrown out. What remains are long, golden coconut fibers. These fibers are suitable for rope making. Others are used in different areas, such as pot filling or animal bedding. At this point, the system works almost like a factory. Every incoming load is scanned, sorted, and classified according to quality. Because the fibers to be used in road construction must be of a certain length and strength. Otherwise, the thread breaks during weaving, the fabric deteriorates, and the foundation of the road weakens. After the quality fibers are separated, the cleaning phase begins. First, they are washed in large water pools. This water bath removes natural contaminants, such as dust, soil, and insect residue from the fibers. Then the fibers are dried with sunlight on large platforms or in special drying systems. This process allows the fibers to remove excess moisture without losing their natural flexibility and durability. The dried fibers are still mixed and scattered. This is where hackling or carding comes into play. This process is similar to the flattening of wool or linen in traditional textile production. In large carding machines, the fibers are separated from each other, aligned and given a flat form. Each fiber is lined up like a soldier and faces the same direction. This makes it much easier to turn them into yarn. Now you have combed, dried, and oriented fibers. The next step, yarn production. This process is mostly done on automatic spinning machines. The fibers are twisted with a twisting motion and turned into 2-ply yarns. This structure gives the yarn both flexibility and durability. The yarn produced may be too hard for fabric production in the classical sense, but it is perfect for engineering projects that come into contact with the ground. Because these yarns are biodegradable, but still perform their function as long as they are decomposed. They also have natural resistance to water and microorganisms. They do not have side effects such as plastic pollution seen in synthetic materials. These yarns are wound on large spools and are now ready for the weaving process. Ready-made yarns are woven on large looms and turned into geotextile fabric. This weaving is much wider and more sparsely spaced than ordinary fabrics. Because the aim is not aesthetic, it is to create a surface that is compatible with the soil, breathable, water-permeable, but prevents erosion. Thanks to the structure of the fabric, when water passes through, it can seep into the lower layers but does not allow the soil to shift. At the same time, it does not prevent the development of plant roots. Thanks to this feature, it both stabilizes the road base and serves the structure without disturbing the environmental balance. During weaving, the thickness of the fabric, yarn tension, and pore size are completely adjusted according to the project it will be applied to. Sometimes these fabrics are laid under the road, and sometimes they are placed on slopes where erosion is intense. Now let's see the application of coir geotextile to the road surface. The first step begins with laying this natural woven fabric on the area where the road will be built. Yes, it is laid on the ground like a carpet. These fibers are only soft in appearance. In reality, they are incredibly durable. The structure of the fibers is designed to prevent rainwater from eroding the soil. In other words, it prevents the soil from slipping, shifting, or being washed away by erosion. Coir geotextile acts as a barrier on the soil, but thanks to its permeability, it also allows water to reach the lower layers. Moreover, this material can be decomposed in nature over time. In other words, it does not fight nature, it cooperates with it. These fabrics are carefully laid according to the slope of the ground and the type of soil, and are tightly attached to the ground. The edges are fixed with steel nails. Why? Because trucks will pass over it. Because this is not temporary, the foundation of a permanent road is being laid. After the coir geotextile is laid, the next step is to create the soil layers. First, large gravel is poured on the fabric. This gravel layer increases the load-bearing capacity and also distributes the load between the lower and upper layers. This is a very important step in road engineering because it prevents the load from being concentrated at a single point and from collapsing. After this stage, it resembles classical road construction techniques. Thus, the coir fabric is no longer visible, but it still continues to function. It balances the water coming from below, stabilizes the ground above, and holds together the ground that will carry the road. Then, another layer of soil is laid on top of this gravel. The upper layer is compacted, and stabilized material is added if necessary. In some areas, asphalt is laid, while in others, the road is left stabilized. But the structure underneath is always the same, a natural network woven from coconut fibers. Thanks to this system, India can build roads in rural areas without the need for reinforced concrete infrastructure costing millions of lira. Moreover, without harming the environment, using local materials, and at much lower cost.